Main steps in oogenesis. Oogenesis begins in the female embryo with the mitotic division of primordial germ cell, give rise to oogonia. Then oogonia divide by mitosis to form cell that begins meiosis but stops at prophase 1. Before birth, each of these developmentally arrested cells is called primary oocyte. Each primary oocyte found within a small follicle. Cavity lined with protective cell. At birth, ovaries together contain about 1 to 2 million primary oocytes. Out of these, about 500 fully matured between puberty and the menopause. Beginning at puberty, follicle stimulating hormone FSH periodically stimulates a small groups of follicles to resume growth and development. Out of these, only one follicle fully matures each month. During this time, primary oocyte within the follicle completes meiosis 1, produces a secondary oocyte first polar body. Then meiosis 2 starts, but stops at metaphase. Secondary oocyte arrested in meiosis 2, released at ovulation, with the first polar body when its follicle breaks open. If a sperm penetrates the secondary oocyte, meiosis 2 completes. Secondary oocyte divides into the mature ovum and second polar body. Both meiotic divisions involve unequal cytokinesis, with a smaller cell becoming polar bodies, which will degenerate eventually. If a sperm penetrates, there is a single mature egg ovum containing sperm head at the end of oogenesis. Fusion of the haploid nuclei of the sperm and ovum is called fertilization. Ruptured follicle left behind after ovulation develops into the corpus luteum. Corpus luteum secretes estradiol progesterone hormones, which help to maintain the uterine lining during pregnancy. If the egg is not fertilized, corpus luteum degenerates, leaves a small permanent scar or fibrous tissue called corpus albicans on the ovary surface. A new follicle matures during the next cycle.